27 problems till now, and today we will try to solve one or two problems. If possible, we can try to solve 4 problems, so we go all the way up to 30, but we will see, depends upon the time. So let's take a look. Let's go to our next problem, which is 27, and see what it is. So this problem has to do with quadratic primes. Okay, so let's start a new notebook. It seems like an interesting problem. So let's start a new notebook, and we will call it problem 27, like that. And let's write the problem down. That's problem 27, and it's called quadratic primes. And let's figure out what is happening with this. Okay, and most of the things are images, so we aren't going to be able to copy it very well. Okay, so let's just put this in. So this is n squared plus n plus 41. So that's the first formula. The next formula is values. It turns out that the formula will produce 40 primes for the consecutive integer values, and over here we have 0, 0 less than equal to n less than equal to 39. Okay, so that's done. However, when n equals 40, when n equals 40 square, okay, let's put that in. N equals 40 square plus 40 plus 1 equals 40 times 40 plus 1 plus 41 plus 41. 1 is divisible by 41, and certainly when and then we have another formula over here, n equals 41. When n equals 41, we have 41 square plus 41 plus 41, and in this case it's certainly divisible by 41. That is clearly correct. Okay, the incredible formula, there is another formula, which is n squared minus 79n plus 1601. That formula was discovered, which produces 80 primes for the consecutive values, and then we have to put in the formula. It's equal to 0 less than equal to n less than equal to 79. Okay, it should be less than equal to, like that. Okay, the products of the coefficients. Okay, so there is a full stop over here, or period. The product of the coefficients blah 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 is that. Okay, coefficients, by coefficients you mean negative 79, that's one coefficient, and 1601, that's the other coefficient. So is that okay? Consider quadratics of the form and we need to put down the quadratics of the form over here. So this is n square plus an plus b, where, and that goes like that, where a is less than 1000 and b is less than 1000. So b, the absolute value of b, is less than equal to 1000. Okay. Okay, so where n where the absolute value of n, like that, is the modulus absolute value of n, modulus absolute value of n. Example, the modulus of 11 is 11, and the modulus of minus 4 is 4. Okay. Find the product of coefficients a and b. That's a and b and b for the quadratic expression that produces the maximum number of primes for consecutive values of n starting with n equals 0. Okay, so fundamentally we want to find the product of the coefficients a and b. So basically we have to find a and b for the quadratic expression, that one. We have to find a and b that produces the maximum number of primes, okay, for consecutive values of n starting with n equals 0. So we basically have to loop over a and we have to loop over b and find the set of values for which we get primes for the consecutive values of n. Okay. Okay, let's try to figure out if we can simplify this a little bit. Okay. Let us see. So let me just erase everything to begin with, and let's talk about the expression. I wish there was some way of erasing everything. I guess I can just move to another location. Okay, so yeah, let's talk about this. So n square, so we have n square plus an plus b for n equals 0, 1, 2 and so on, will give us primes. Okay, a is basically between minus 999 and 999, and b is between minus 1000 and 1000, and this should give primes for if we put n equals 0, then this expression, if we call this function of n equals b. Okay, right away we know that b is a prime. Why? Because it has to be something that starts with n starts with 0, so we know it has to satisfy for n equals 0. That means that we don't actually have to solve for all the values over here. We just need to solve for all the values in which b is a prime. So I think we can create a wait. This also means that we don't care about negative values, because negative values are not prime. Okay, so that's a great thing to know. And so b can be only positive values. B is between 1. We will not consider 1 because yeah, it's not very meaningful. And then we will find all the primes up to 999, and that's not that many primes. So let's use the sieve algorithm to find the primes to begin with. So find primes, and I don't even think that I need to write a function. So find the primes up to 1000. Okay, 1000 is obviously not a prime, so I can get something like okay, so let's import numpy first. numpy as np. Okay, now we go all the way from 1 to 1000, and that's gonna be everything till 999. So B's are these things. Okay, and we want to start with 1, not 1, actually we want to start with 2. 2. Is 1 a prime number? Is 1 a prime number? Why isn't 1 a prime number? Okay, which means 1 is not a prime number. Never mind. Okay, so we start with 2 and go all the way till 1000, and then after that bs equals np bs, where bs percentage 2 is not equal to 0, right? And let's look at what bs is. Okay, so something obviously went wrong. bs is that bs percentage 2 is that okay, not equal to 0 is true false. Okay, so this is the condition we want. If we have this and we say bs sorry, not equal to 0. We have that, so we have eliminated the even numbers, and then we continue. Oh, okay. Bs, length of Bs is greater than 0. We will continue doing this. Append Bs 0, like that, and then I will update Bs equals Bs 0 Bs percentage that is not equal to 0. And if we look at Bs now, it's an empty array, but if we look at primes, that's a list of primes. So these are all supposed to be primes. 2, 3, 5, 7, 11, 13, okay. So we have a set of B's, we have calculated B's, and B's can only be one of these things. So instead of looking for 2000 different values, we only need to search 168. So we have one of the loops we have reduced significantly just by putting this condition. Okay, so this gives me hope that we can reduce these things even further. So let's try to reduce this even further. If now we put n equals 1, f of 1 is going to be equal to 1 plus an plus b, right? And this also has to be prime. This has to be prime. Which means that for every value of that's a prime. So let's say I'll have primes minus b minus an, this n becomes 1. Let's remove that n becomes 1. Okay, so minus b minus 1 is equal to a. So a, we only need to search within this space. Okay, a will be one of these numbers, right? Because a has to, for n equals 1, this has to be a prime. The only thing is, it doesn't have to be limited to the primes that we have calculated. It can be a prime that is as big as it needs to be. It has to be anything between minus 999 and a and 999. So we have a range of values of a, and we need to find which of these is within that. So let's find a list of candidates for a. So we have a list of candidates for b, and we just need to find a list of candidates for A, and then we are going to go ahead and start seeing whether these things start creating primes or not. So how do we do this? Okay, let's try to figure this out. So we have B's, that's a list. B's equals B's, and so this is a number array, right? Okay. For A in minus 999 to that A, if one plus A plus B, 1 plus A plus B in B's, because that 1 plus A plus B, oh yeah, I don't think this is going to work out. Let's just loop for A in range minus 999 to 1000. Okay. For B in B's. Okay. Let's look at candidates. Candidates is nothing. Okay, and we know that it has to I think we need probably need a larger set of primes for this. I believe we need a larger set of primes. Let's take a look. This straight up starts with 41 and then it keeps on going. Okay, let's say for n in range 40, for example, print n and n square plus n plus 41 and 41, 43, blah blah blah. It goes all the way to 1601. So that's a very large number. Okay, it's way beyond the 1000 mark. What about n square minus 69n, n square minus 69n plus 161601. Okay, it's something that keeps on decreasing and comes to 431. Oh wait, this will go all the way up to 79. 80 primes. 80. So this keeps on decreasing, and then it increases. That's fascinating. It decreases and then increases. So that's the key. That's the key. You need to have something that decreases and then increases, and that's going to give you something that produces the maximum number of primes. Let's see. And that's the reason why you have the negative sign over here. It will allow you to do that. So let's say we have that. Interesting. And those are all primes. What's the center over here? The place where it becomes a minimum. Do we know? Can we figure this out? We should be able to figure this out. This is n square minus 79n plus 1601. So if we differentiate it, 2n minus 79 equals 0. So n equals 79 by 2. Okay, so approximately a little less than 40. 601. So this doesn't really matter. Okay. So this value, the closer it is to, let me see, n square plus an plus b, this value, the closer it is to minus 500, the better it should be. So it's a number in that range. Okay. So let's see whether we can find the candidates for this. That's a prime, that's a prime, that's a prime. And if we have a negative 500 around here, you're going to get a 1. Okay. It starts off with a large number, so it starts off big. So if it starts off with, for example, 997, and this is a negative 500 or something like that, then we might get something that is close by. Okay. That's interesting. Okay, so we are going to try to solve this problem by just looping over. Let's create a function is prime, and let's say and this is going to return true or false, and for I in range 2 to sqrt and p dot sqrt of n, and we want to check the flow, or and I'll give a +1 for that, +1. Okay, if n%i is 0, return this is not a prime, and if you go all the way over here, return true. Okay, and so we have a function that will return whether something is a prime or not. Is prime 4, and the answer is it is not a prime. But if we have something like 73, it is a prime. 74 should not be a prime. 74 should not be a prime. Okay, another sanity check for I in range 2 to 100, 2 to 1000. Okay, if is prime I print I, and we should be able to get the same values over here. 997 is the last one, and 991. Okay, so this looks like this is prime function is okay. So let's see. Okay, so n primes is 0. So for this combination of a and b, for this combination of a and b, we want to see how many will be prime. So for n in range 1000, 2000, whatever, 5000. Okay, if n squared plus a n plus b is a prime, if is a prime, if that is a prime, then n primes plus equal to 1, and else break. Okay, so if we get to an n that is not a prime, then we just break out of here. And so at this point we will say max length is 0. Okay, if n primes is greater than max length, then max length equals n prime, and let's print max length. Let's print a, and let's print b, and let's also print a times b. Okay, and let's see how many we get. Okay, so we have a problem. There should be an if condition over here. Convert float nan to an integer. Float nan. And we if this is v is that if v is less than 1, break. Okay, 71. That's a bummer. Oh, we didn't get this because this is greater than the limit. Okay, so that's the reason why we did not get that. Okay, but with 61 and 971 as the values, we get 71 primes. Is that correct? Let's test it. So minus 61 and 971, and we're supposed to get how many? 71 primes. What is y? It does look interesting, and these are all primes. How about the last one? This also looks like a prime. is prime 1601. 1601, is that a prime? It is a prime. Okay, and we've maxed out on this 971, more or less maxed out on this. Okay, this seems to be the answer. Find the product of the coefficients. This seems to be the answer. Let's take a look. All right, so we've solved one of the problems. Okay, so we have solved problem number 27. Let us solve maybe one more problem if possible, and then we'll call it a day. So problem number 28. Number spiral diagonals. Wow. Okay, let's solve this. This seems to be an interesting problem. I think this deserves a new notebook. This is problem number 28, like that, and problem 28, and this is called number spiral diagonals, like that. Okay, and let's copy this. Uh-oh. Okay, and we can't write in red, so starting with the number 1. Okay, that's 1, and move to the right. Okay, so this in a counterclockwise direction. Okay, so we move over here to the right, and then we go counterclockwise 2, 3, 4, 5, like that, and then we move to the right, and then we move counterclockwise like that. A 5 by 5 spiral is formed as follows. So okay, so that's a 5 by 5 spiral. That is correct. It can be verified, the sum of the numbers of the diagonals, sum of the numbers on the diagonals, so that's the red numbers, that's why they've colored it red. Okay, is 101, if you say so. Okay, okay. What is the sum of the numbers of the diagonal of a 1001 by 1001 spiral formed in the same way? Can we actually form a 1001? Because it's an odd number. Okay. Understand. Okay, so let's see how do we solve this problem. Let me get back to my problem over here, and let's spread this out a bit. Okay, and let's start looking into the problem. Okay, so we have a 5 by 5 will have, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, it goes one more, 17, okay, 18, 19, 20, 21, 22, 23, 24, 25. So there are 3, 1, so that's one, that's the other one, and that's the third one. 3 squares in here. The first one is if we put n equals 1, that's a 1 by 1 square. N equals 2 is a 3 by 3 square. N equals 3 is a 5 by 5 square. And n equals 4 should be a 7 by 7 square. Why? Because this is 5 and I need to add 2 more things. It should be a 7 by 7 square. So and so we see one pattern emerging. A 5 by 5 square will have numbers 1 all the way to 25. This one will have numbers 1 all the way to 9, right? This one will have numbers that go from 1 to 1. Okay. Okay. This one will have numbers 1 to 49, right? Because there are just that many numbers, n by n squares, and so on. So okay, let's see. So this diagonal, the last one, that one will be these numbers. That's easy to get. So the question is, what would be the other numbers, right? That's what we have to figure out. So let's look at this. We know 9 happens to be one of the numbers. We need to find out the 3 other numbers associated with 9. So the 3 other numbers are, maybe I will use a different color. The 3 other numbers are 7, 5, and 3. So given 9, because we can figure out 9, this should be 7 and 5 and 3, and this is for n equals 2, which is a 3 by 3, a 3 by 3 square. 1 is just 1, it doesn't matter. How about 25? This thing over here. So 25, that I need to find this one, and this one, and let's see if we have a pattern emerging. This is n equals 3. That would give a 5 by 5, right? So this is a 2 times 2 minus 1 and 2 times 2 minus 1. This is a 3 times 2 minus 1 and 3 times 2 minus 1, and the next one is going to be the 7 is going to be 4 times 2 minus 1 and 4 times 2 minus 1. Okay, so that's how we get the ends. And if we get the ends for n equals 4, we have a 7 by 7, which is that, and this should be a 49. And what we have to do is figure out what these three numbers should be. So for 25, okay, it is 21, 17 and 13. Okay, so the difference between these two is just 2. So 7 and 2 9, 5 and 2 7, and 3 and 2 5. Okay, so that's 2. The distance between this is actually 4. That's 4. 17 and 4 is 21, and 13 and 4 is okay, and that makes sense. It starts with 1, then it expands by 2. Okay, this expands from 2, it expands by 2 more, so there'll be 3 and 2 5, so that's 4, and then it will expand by, let's write the next set, 25. So this is 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, and we have 49 like we had predicted over here. Okay, so that's good. We had 4 over here, right? Now we have 1 2 3 4 5, which is that, minus 1 is 4, and now we have 7 minus 1, it should be 6. So if we are trying to figure out what these values are, so we have 49 and the values are 43 and 37 and 31, then this is 7 minus 1, so that should be 6, right? Okay, 43 and 6 is 49, 37 and 6 is actually 43, and 31 and 6. Okay, so that is 1 minus this value over here. So I think we have figured out how to solve this problem. It's fairly okay. So n equals 4. N equals 4 means 2 into n minus 1, that many times 2 into n minus 1, that many that size of square. So we need to figure out for 2n minus 1 equals 1 0 0 1, what is n? So that would make it 2n equals 1002, and that would make n equals 1002 by 2, that is 501. We need to have n go all the way till 501. Okay, we will start with n equals 2 and go all the way till can you see that? Yeah, we will start with n equals 2 and go all the way till n equals 501, and that should give us the solution. Okay, let's solve this problem. This should be relatively simple. Okay, so let's say we want to solve an n equals capital N equals 5. Okay, we want to solve a 5 by 5 problem. That's and then later we will put this equal to 1001. Okay, let's not call this n, but let's call this square. Okay, so now capital N equals, like we found over here, is this square plus 1, okay, divided by 2. So that's so where is divided by 2? There you go. That's 3. And if we make the square equals 25, it's a 5 by 5 square, then we will get it when n equals 3 in our case. So that's good. Now we want to figure out if n for I in range, so I have to go from 2 to this capital N plus 1. Okay, print I. So we have 2 and 3, so that's what, so we have this and this, and when n equals 2, okay, this value we will call this value, this value we are going to call v. This number, that number we are going to call v, and that v maybe I should call this n. I will call this v equals 2 into n minus 1. Okay, so if we print v as well, we will see that this is n, and if we go up to a square of, we can go up to a square of 7 by 7 square. In that case, n is going to go all the way up to 4 over here. Like that. And we will see that for 4 we have the value 7 we have calculated, and now we want to figure out this value over here, which is 1 minus 7. We will call this value v1 equals 1 v minus 1. So we will call this v1, which is 6, is the number we have to move through. Okay, then we need to find the four values. So we start with it starts with n squared, diagonal values equals, it starts with n square, so n square, okay, for I in range 4, okay, we just put equals n square minus I into v1. So that's the diagonal values, and let's see if we get the right diagonal values over here. Uh-oh. This should be 9, 5, that's v1, so for n equals 2, it's a 3 by 3 this thing. For I equals 0, it's 2 square is 4, but it's not n square, it is v square. Okay, so now we have 9753. For the 3 by 3 we have 25, 21, 17, 13, and for the 7 by 7 we have 49, 43, 37, and 31. So we are going in the right direction. Total, this one is for the 1 and the center over here, so we start with this, and total plus equal to diagonal values, the sum of this, okay, the sum of this, and we don't need to print this. Okay, and we just want to figure out what the total is. Okay, let's set this to a 5 by 5, and the value is 101 as it says over here. Okay, so this is a 5 by 5. We want to set it to a 1001 by 1001, like that, and the result is this number over here. You must wait 8 seconds. I don't know why do I have to wait 8 seconds before I answer? Okay, so we have solved 2 more problems, and we will stop over here. I think it's already over an hour, so we'll stop over here and we'll continue next time. So thank you for watching the video. I will be uploading this on YouTube as well. If you like videos like this, please like and subscribe, and I will see you next time. Bye bye.